Good afternoon, everyone. This is Pranay Davaskar here. Okay. So today we are going to learn robotic 5.0. Okay. We have started from robotic 1.0, then we have done 2.0, 3.0, and 4.0. In the last session, we had done 3 different kinds of board. That is a black line follower board, white line follower board, and the edge follower board. Okay. In today's class, we are going to do 4 different kinds of board. And this time also, all the 4 boards will be non-programmable with the hardware itself. Okay. So let's start. Everyone is ready? Okay. We'll start it. Okay. So as per the last session, here also we are going to start with planning first, designing and prototyping. So in short, we are going to divide the work in 3 different parts. That is, we have to plan what we are going to do it. We should know which board we are making. Then we should have all the accessories which is required, all the wires, components, and then we have to test it. That is a prototype. So the first thing we require is all the components as of we had discussed it in the earlier session, that is in robotics 4.0. We will be requiring a robotic chassis, 2 DC gear motors, 2 mounting brackets to mount the motor, pair of IR sensor. This time we require a pair of LDR sensors. Okay, that is a new thing which is included. That is a new sensors we had included over here. And we are using the same motor driver, that is L298N, to drive the tires. 1 breadboard, connecting wires to do the connection, and a battery for the power supply. Okay. So the starting with the first component, what we have is a proximity sensor. Okay. Proximity sensor is the same IR sensor which we had used for the line follower. Okay. So this IR sensor also has 2 LEDs. The white one is the transmitter and the black one is the receiver. Okay. So the working of this IR sensor is same as we had explained earlier in our old sessions. Over here, as you can see, we have white LED, which is a transmitter, a black LED, which is a receiver, and we have 3 terminals. That is output pin, OUT, the GND pin, which is the negative pin, and the VCC pin, which is a positive pin of it. This IR sensor, in this IR sensor, we can also adjust the sensitivity of it, okay, by wearing this knob over here. Okay. This IR sensor also works on the same principle, that is the infrared rays. Now moving to the next component, what we have is the LDR sensor. Okay. In the LDR sensor, we have it is also called as photoresistor. Photo means light. So this LDR sensor, the full works on a principle of a light. So if the light falls on this red color filament, it is going to work. Okay. The full form of LDR is light dependent resistor. So in short, it is a resistor which changes its resistance when the light falls on it, in short. Okay. As you can see over here, it also has a 3 terminals. One is the out terminal, that will be D0, that is a digital output. The other will be GND, the middle pin, that is a negative terminal. And the last one is the VCC, which will be a positive terminal. Okay, so how this works is when it is in a dark place, when the sensor is connected in a circuit and it is in a dark place, it its resistance is maximum. Okay, when the light falls on it, its resistance gets reduced so that it starts conducting. So that's the principle of an LDR sensor. So in today's class, we are going to do 4 different kinds of board. That is, using the IR sensor, we are going to do 2 boards, and using an LDR sensor, we are going to do 2 more boards. Using IR sensor, that is IR proximity IR sensor, we are going to do obstacle follower and obstacle avoider board. And using an LDR sensor, we are going to do, that is, a light follower and light avoider board. Okay, so we require a pair of LDR sensor, a pair of proximity IR sensor. Okay, so as we had discussed in the earlier session also, we require a motor driver to drive both the motors of our chassis, okay, to power it up. And the function of a motor driver is to control the direction of the motor as well as to boost the power as per the required of the motor. So this is the motor driver L298N, which we are using, the same one, which has this IC. And over here are the connectors, blue color connectors, where we have to power this up, motor driver first. So from here, the power will go to our IR sensor. Okay, so from the battery to the motor driver, we are getting a power of 12 volts, or we can put a 9 volts also. So from that is connected over here, where it is written 12 volts. And it has a common negative pin, that is a GND pin, and a plus 5 volts. From here, the power will be delivered to all the IR sensors. Okay, so this is a motor driver which is required to drive the motors in short and to boost the power as per the requirement. So the first board, that is the 4th board which we are going to learn, okay, in today's class, that is the obstacle avoider. As the name says, if the obstacle comes in front of this board, it is going to avoid the obstacle. In short, it is going to dodge and it is going to change its direction. Okay, so this is our robotic car chassis in which we have placed both the sensors. Here we are using an proximity IR sensor. Okay, these are the IR sensor, not the LDR ones. Okay, so these are the IR sensor, which looks something like this. Okay, which has 3 terminals, that is a positive, VCC, GND, and the output terminal. And this knob is given for every sensor to adjust the sensitivity of it. Okay, means how far it is going to sense. You can adjust the distance. That's it. Over here in this proximity IR sensor, there are 2 LEDs. One is this, and the second one is this. One LED is to indicate if the IR sensor is on or off. And the second one turns on when it detects something. That can be any object. Okay. So this is the 4th board as per the last class, because the first board which we had done was a black line. The second one which we had done was a edge follower. The third one was a white line, and the 4th one is a obstacle avoider board. Okay, so this is a chassis which we require. Okay, I'll show you. So this is a chassis which we require. Okay, so it has 2 motors mounted with the help of a T-clamps. Okay, 1 mono wheel to turn to the left or the right. Okay, so this is what we require. So over here, as you can see, the 2 IR sensors are placed in the front of the chassis, one in the left hand side and one in the right hand side corner. Okay. This board is also a non-programmable board, so we are not using any microcontroller to control it. So the components we are using is IR sensor, a pair of IR sensor, a breadboard. A breadboard is used to do a temporary connections. Okay. A motor driver, that is L298N, and a battery holder to power all the components which are assembled on the chassis. Okay. So as you can see over here, once we connect, I'll show you the wiring diagram in the next slide. Okay. So if this black color part is an obstacle which is in front of the board, so then the board is going to take a left turn. Okay. It is going to dodge this obstacle and select some other part. So it won't hit the obstacle. Okay. So that's why it is named as this obstacle avoider. Okay. In this condition over here, our right sensor is sensed by this obstacle. Okay. So this turns off so that our board takes a turn towards the left. Okay. I'll show you that in a flow chart how it takes a left. Okay. The working principle of it. Now we'll move to the connection to do our first board, that is the obstacle avoider. Okay. In the obstacle avoider, okay, you can see over here, this is a left proximity sensor, left proximity IR sensor. This is a right proximity IR sensor. All the red wires are the positive ones. Positive means those are all the VCC wires. Okay. And all the black wires are the negative wires. That is GND wires. So from the left sensor, the VCC wire goes to the breadboard, which is connected vertically in one line. So this VCC of the left sensor has to be connected with the VCC of the right sensor. That's why the right sensor wire, right sensor VCC line is also connected in the same line on a breadboard, on the first row. Okay. You can select any row, but you have to make sure that VCC goes in the same line and the GND, that is black wires, goes in the same line. Okay. So this GND is also taken from the left sensor and connected it on a breadboard, that is in one line. From the right IR sensor also it is taken and it is connected below the old GND wire. Okay. And the blue wires are the output wires. Those are the signal which is sensed by the IR sensor and which has to be given to the motor driver so that the motor driver will take a decision which tire to stop, which tire to move. So over here, the output, that is a blue wire, is connected to IN1. You can see over here, it is connected to IN1 pin. These are the enable pins. Okay, you can say a signal pin. If the signal is detected by the IR sensor, then it will send some signal which will go to the motor driver. And then the motor driver is going to decide which motor to stop, which motor to move. Okay. As you can see over here, each motor has two pins, that is IN1 and IN2 pin. Okay. Each motor has given two pins, so we can control the direction also of the motor. Like in clockwise, it has to move in forward or a reverse direction. Okay, so right now we had connected our left sensor to IN1 and our right sensor output pin to IN3. We had not connected to IN2 because IN1 and IN2 are allocated for the left motor. IN3 and IN4 are allocated to the right motor. Okay, so these are the output pins. So from here, from the breadboard, we are connecting one male-to-male wire. So it is power. So from the motor driver, the power is going to the breadboard. So breadboard is also getting powered up. So from here, the power is given to the IR sensors. So this red wire is going to the 5 volts on the motor driver. Okay. And this GND, that is a black wire from the motor driver, is going on a breadboard, on the GND line. Okay. So this is a positive line, which is with the red wire, and this is a negative line, which is with the black wires. Okay, so and this over here where it is written as plus 12 volts, here we are giving a battery or external power source which is going to the motor driver first. From the motor driver it is going to the breadboard. From the breadboard it is going to both the sensors. So this 9 volts battery is connected to the motor driver which powers these motors also, including it is powering up the IR sensor also. So the working voltage of this IR sensor is a 5 volts. Okay. So this positive red wire, as you can see over here, is going with the switch to the battery. Okay. And the negative, the black wire, is connected to the common. That is, all the negatives are connected together. So as you can see over here, this is a connection for obstacle avoider. That is our first board for today's session. In that, the output pin of left sensor is connected to iron 1 as I have shown in the diagram. Okay, and the output pin of the right sensor is connected to iron 3. Okay, now we'll move to the next slide, that is a flow chart. Okay, a logical reasoning how the bot is taking a turn. Its sensor objects towards its right sensor. Okay, I'll just zoom in this. Okay. So as you can see over here, this is our robot. Okay, a car bot. This is my left IR sensor and this is my right IR sensor. When an obstacle is placed in front of both the sensors, okay, so we'll go with the first condition. From the start, if both the IR sensors are off, okay, no, then come over here. If both the IR sensors are off, then your robot should, what it has to do? It has to stop because it's an obstacle avoider. Okay, so in the normal condition, when we do all the connections, both the tires should move. Okay, it should be working, it should not be in a stop condition. If we place our hand or any obstacle, that time both the tires should stop. Okay, that's why I had said that if both the sensors are off, then your robot should stop. Okay, that is the first condition. Now when we are going to, if the left sensor is off and the right sensor is on, okay, over here in this condition. So this is the left sensor and this is the right sensor. So the obstacle is placed in front of a left sensor. So this sensor turns off. Okay, so if the left sensor turns off and the right sensor is on, then your robot should move to the right direction. That is, it moves in the opposite direction. If the left is off, it will take a right turn. If the right sensor is off, it will take a left turn. This is for the obstacle avoider. Okay, it is going to do opposite. Okay, so in short, when this left sensor is sensed by this obstacle, okay, this tire stops, the opposite. Okay, the diagonal tire stops. So the right sensor is connected to the left tire and the left sensor is connected to the right tire. It's a cross connection. So when the left sensor senses an obstacle, the right tire turns off. So it takes a right turn by moving the left tire. Okay. Now moving down in the second condition, that is left sensor is on, this sensor is on and the right sensor is off. Okay, so when the obstacle is in front of the right sensor, okay, now that time the right sensor will turn off. So the left sensor is on, so it is going to take a left turn. When the right sensor is off, it is going to move to the left. Okay, and in the last condition, that is if both the sensors are on, okay, that time it is going to move forward continuously because Nobody is obstructing it and nobody is stopping the bot. Okay. So this was our first bot, that is an obstacle avoider bot. Okay. It is avoiding the obstacle which is coming in front of it. Okay. So now the next bot which we are going to learn is an obstacle follower bot, the opposite of avoider. Now this time in the avoider, it is to dodge the obstacle and it is to take a turn and move to the other path. Now it is going to follow the obstacle which is coming in front of the robot. Okay. So we'll move to the obstacle follower bot. Before that, I'll show you a video of an obstacle avoider bot. Okay. So this is a short video of an obstacle avoider bot. Okay. Can you see the obstacle is touching to the right sensor, it is going to the left. Okay, I'll play the video again. See, when the obstacle is placed in front of a left sensor, it is taking a right turn, opposite turn. Okay, so this was a video of an obstacle avoider bot. Now, this is our first bot, that is an obstacle avoider. The second bot which we are going to learn is opposite of this. So the sensors and the connection is going to change, but the sensors are going to remain the same. That is a proximity IR sensors are also, we are using in this also. Okay. So as you can see over here, this is a component placement for an obstacle follower bot. Okay. Obstacle follower. Can you see this images diagram at the bottom of the screen? A car, in front of a car, obstacle is placed, okay, and the obstacle is moved, so the car is following the obstacle. Okay, so here also everything remains the same. That is, the placement of the IR sensor is same, the breadboard placement is also the same, the motor driver is also the same. Only the one thing is going to change is the connection. Okay, I told you before only that we are connecting an iron pins, that is a digital pins which are taking the signals. Okay, so this is a circuit connection for an obstacle follower. Everything remains the same, that is all the red wires, all the VCC are connected together, all the GND wires are connected together on a breadboard. Okay, the only thing is going to change is this. Can you see this over here? That is output pin of LS is going to iron 3 over here. Okay, over here. So, and the RS is going to iron 1. Now it's changed. Okay, I'll just take back to the old slides. Okay, so over here in the obstacle follower, left sensor is connected to iron 3 and right sensor is connected to iron 1. And as we had discussed earlier in the obstacle avoider board, our left sensor is connected to iron 1, that is opposite. Now it's iron 3, before it was iron 1. So what we had done is we had just interchanged the wires of the output from the both the sensors. So the wire which was going to iron 1 now will go to iron 3, and the wire which was going to iron 3 will go to iron 1. Okay, see here, LS was equal to iron 1, and right now what we are doing is LS is equal to iron 3. We had changed it. Okay, because now before it was opposite, the diagonal connection was there, and if we place the obstacle in front of a right IR sensor, it is to take a left turn. Now as we had changed the connection, if we place the obstacle in front of a right IR sensor, it is going to move towards the right in the same direction as the obstacle is. Okay. So this is a connection for the obstacle follower. Everything remains the same. All the VCC are connected on the breadboard. Okay. All the GNDs are connected on the breadboard. From the battery, the 12 volt is going. Okay. From the switch to the motor driver. From the motor driver, it is going to rest of the components, that is through the breadboard and to the IR sensor. Okay. So now we'll just go through this. There is a flow chart, so you'll get a better idea how it is taking a turn. Okay. So in the obstacle follower, if both the IR sensors are off, what it is going to do if both the IR sensors are off? It is going to stop. Okay. It is going to stop. Then when in the second condition, we'll go to the second condition. When the left sensor is on and the right sensor is off. So this is off and this is on. When the left sensor is on and the right sensor is off. Okay. And the obstacle is placed in front of a right sensor. So it is going to follow the obstacle and it is going to take a right turn. Okay. In the third condition, when the left sensor is off and the right sensor is on, but the obstacle is placed in front of a left sensor, then it is going to follow the left turn. It is going to take a left turn. Okay. And in the last condition, okay, when both the sensors are off, okay, it is going to stop. So if we place an obstacle, okay, in front of our board, it is going to stop at that moment of time. But in the first condition, if we place an obstacle, and for example, this is our board, and if we place an obstacle in front of it, and if we move the obstacle, our board is going to follow that obstacle towards it. Okay. So this was a connection and the logic for the obstacle follower board. Okay. So this is a short video for the obstacle follower, in which you will be able to see if we place an obstacle in front of a right IR sensor, it is taking a right turn. Okay. Okay, I'll play the video again. See, we are placing the obstacle in front of the sensors, so it is following the obstacle. Okay, so till now we have learned two different kinds of board using the same sensors, that is an obstacle avoider and an obstacle follower. Okay, now we are going to use a different pair of sensors, that is an LDR sensor. Okay, in which we are going to do more two boards, that is a light follower and light avoider. Okay, so this is our third board, what we are doing. Okay, as you can see over here, the placement of the sensors remains the same. Okay, but instead of the IR sensor, we have to replace this with an LDR sensor. Okay, I'll show you how the LDR sensor looks like. Okay, so this is an LDR sensor. Okay, this is the sensing part of it. Okay, it has a photo cells inside it. So when the light falls or of a torch of a light or directly sunlight, its resistance decreases, so the conductivity increases directly. So it starts working if it is in stop condition. Okay. So over here, everything remains the same. That is, we have an over here right now we have two LDR sensors instead of an IR sensor. The placement also of the sensor will remain the same. Okay. We are having a breadboard, a motor driver, and a battery. Okay, as you can see in the images down below, we are using a torch. Okay, this torch, the light is falling on the left sensor. Okay, so right now the bot is going to move towards the light. That's why it is named as light follower. If the light falls on the right sensor, then the bot is going to move towards the right side of it. Okay, so as you can see over here, these are some diagrams in which the light has been projected on the sensors. Okay, now I'll show you the connection. Okay, so this is a wiring diagram of it. Okay, in the wiring diagram, this is our LDR sensor. Okay, we are using an LDR sensor over here. This is a right LDR sensor. The naming is a bit wrong, so please ignore that. Okay, and this is a breadboard. So over here also, all the red wires are our positive wires, that is a VCC, and all the black wires are our negative wires, that is a JND wires. Okay, so in this condition, the connection remains the same. As we had known, for the obstacle avoider and the obstacle follower, everything was same. Only we used to change is the output pin of it. Okay, the wire which was going to iron 1, we used to remove it and interchange it with iron 3. Over here also, it's the same thing. The left sensor in this condition, the left sensor is connected to iron 1. Okay, our left sensor is connected to iron 1 and our right sensor is connected to iron 3. Okay, so I'll just show you the light follower diagram. For example, in the first condition, what we have is our both sensors are on. Okay, in this initial conditions, we had put it 2 flashlights and we had turned on our left sensor also and the right sensor also. In this condition, when our bot is sensing some amount of light, then it is going to move towards that light. So that's how it is going to follow the light. Okay, that is our first condition. In the second condition, when the left sensor is on and the right sensor is off. Okay, when this sensor is on and the right sensor is off. So the flashlight has been placed in front of a left IR sensor. In this condition, the bot is going to move towards the light, that is towards the left direction. Okay. In the third condition, when the left sensor is off and the right sensor is on and the flashlight is falling from the right side, it is going to move towards the right side of it. Okay. In the last condition, when both the sensors are off, there is no light. Okay, that time the bot is going to stay in the initial condition. It is not going to move from its position. When it will sense some light, it is going to move forward, or else it is going to be in its initial position of it. Okay. So this is a video of a light follower using a mobile torchlight. So as you can see, when it is sensing to the left, it is going to the left when the left eye sensor is on. And when the torch is placed towards the right side, it is taking a right turn. Okay, I'll play the video again. Okay, so this was our third bot, that is a light follower. Okay, the last bot which is remaining, that is a light avoider. Okay, so we'll move to the last bot, that is a light avoider. So as you all know, it's all opposite, obstacle avoider and obstacle follower. Now we had discussed light follower. Now we are discussing light avoider. So as the name says, it is going to avoid the light. Okay. So what it is going to do, as you had, okay. So what it's going to do is if it sends a right sensor, okay. For example, the obstacle is in the right side, okay. The light is falling from the right side. Then it is going to avoid the light. So avoid the light means what? For example, if the right light is falling from this side, then it is going to move to the opposite direction. That is this direction. It is avoiding the light of it. Okay. As you can see over here, as we have shown in the image, the light is falling on the left side of the sensor. Okay. Okay. And that time the board is turning towards the right direction. That is a opposite direction of it. Okay. So in this condition, the light is falling in the left sensor and the board is moving towards its right direction. Okay. So what we have to do for the light avoider board, once we do all the connection, place the board on the floor or a table, then take a torchlight. It may be a phone torch also or a normal torchlight. Okay. And try to place the torch in front of a one IR sensor. Okay. That time, if the bot is following the light, that time it's an obstacle light follower. If the bot is taking a turn, it is avoiding the light. That time it is a light avoider. If you want to make from light avoider to the light follower, you have to just interchange the iron pins. Okay, I'll show you what the iron pins. Okay, over here you have to just remove this wire from the iron 3 and place it on iron 1, and the wire which is going on iron 1, you have to place it on iron 3. That's how you're going to interchange the connection of it. Okay, coming back to the last word, that is in light avoider. Okay, as you can see, the light is falling on the left sensor, the bot is moving towards the right side, it is avoiding the light. This is a wiring connection for the light avoider, which almost remains the same, only we are going to change, as I had told you, the iron pins. Okay, as you can see, LS, that is a left sensor, is equal to iron 3, and RS, that is a right sensor, is connected to iron 1. I'll show you. In the previous thing, for the light follower, the LS was connected to iron 1, and right now we had connected LS to iron 3. So we had interchanged the wires. That's how we are controlling which motor should move when the left sensor or the right sensor is sensed. Okay, so you can just note down this connection. Okay, this connection, because this is the last board, this connection will remain the same for all the 4 boards, that is obstacle follower, obstacle avoider, light follower, and light avoider. Only thing you're going to change is the iron pins which are connected over here. Okay, that you have to see which tire is moving and which side the board is going. Okay, so please, if you want, you can just see this diagram and note down the connection, which wire is connected where. All the red wires are the positive wires and all the black wires are the negative wires. Okay, and this connection is for the motor from both the sides. Okay, please, this is the connection for all the boards. Okay, only the iron pins, that is the output pin, is going to change. Rest everything is going to remain the same. So you can note down this connection. So what you can do is you can buy a pair of 2 LDR sensors, okay, and 2 IR sensors. Using the LDR, you can do a light avoider board, okay, or light follower. And using an IR sensor, you can do an obstacle follower and an obstacle avoider board. Okay, so I'll move to the next slide. This is a logical reasoning, that is how actually it is going to avoid the light. Okay, so as we had discussed earlier, when the light will fall on both the sensors in the obstacle avoider case, the bot is going to stop. So if it sees a light on both the sensor, it is not going to move. It is going to stop at its stage. Okay. In the second condition, where we can see when the left sensor is on and the right sensor is off, okay, that time it is going to move opposite. If it is getting pushed from the left hand side, it's going to move to the right side. So in this condition also, it is sensing the light from the left hand side, so it is going away, that is it is moving to the right side of it. Okay, as you can see over here. Okay, the LED, the flashlight has been placed to the left, is falling on the left sensor, so the our bot is taking a right turn. Okay, and in the third condition, when the left sensor is off, there is no light which is falling on it, and on the right sensor it's on, the light is falling on the right hand side, right sensor. That time the bot is moving towards the left direction, the opposite of it, so it is avoiding the light. And in the last condition, when both the sensors are off, okay, when both the sensors are off, then your bot should move in forward. Okay, that it will continuously move in forward when there is no light falling on it. When the light will fall on the sensor, it will stop. If light is falling on both the sensor, it will stop, and if the light is falling on the right sensor, it is going to move to the left side. Okay, for obstacle light avoider. Okay, so this is a logical reasoning how it works actually. Okay, so this is a video of a light avoider. You can just see when the light is falling, it is just going away from the light. See, the light is falling on the right side, it's taking left turn. Okay, now the light is falling from the right side, it is going in the opposite direction. Okay, I'll play the video again. As you can see, this is pure hardware. There is no microcontroller involved in this. Okay. So these were all the bots which we had studied for our robotics 5.0 session, starting from obstacle avoider till obstacle light follower. Okay, so anyone has any doubts, any question, can unmute yourself and ask me the question. Anyone has any doubts regards to the connection or the wiring? Okay, fine. So we'll end our session over here only. So these were all the bots which we can do without a microcontroller from robotics 1.0 to robotics 5.0. So from the next session onwards, we are going to do new different bots using a microcontroller. Okay. Yeah. Thank you.